Hey everyone, thank you for being here on the last day and an early session. So let's start. So today we're going to talk about demand forecasting for a food retailer. We're going to just start with explaining what the problem is and what we are trying to solve here. Then start with how we are ingesting the data, how we are cleaning, transforming, and enriching the data. Then how we do the model selection and how we're training the machine learning model. After that, we're going to see the scoring part and how the results which are retrieved from the model are sent back to the system of the client. And then at the end, how we can run all of this in production. All right, so let's start with the problem. So in retail, the right quantity is very crucial for success. Specifically for food retailers, they struggle sometimes with bad forecast, and at the end, a result is a lot of food waste. And we want to help a food retailer with demand forecasting solutions so that they can drive their sales, but also lower the amount of food waste. We are going to talk about a bakery chain. In this example. So they have stores in many different locations, and on each location they have different type of products that they are selling. So we want to know how much we're going to sell from bread A in a location A of the chain. So the first step of the project was the ingestion of the data, and here we were working with XML files on an FTP server. Not the best combination. So the data was coming from their ERP system, which could only generate XML files. And this data was available once a day and was landing on an FTP server. These XML files were supposed to be translated into a format that is then easier to work with, like Parquet or a Delta format. And typically for the ingestion part, we use Azure Data Factory to get the data. But it was not really possible here to use this tool to also process or translate this into another format or to just read the content of the XML files. So for this, we used a Spark XML package in order to translate the XML file to a Delta format. So at the end, our architecture for the ingestion part looked something like this. So we used Azure Data Factory for two purposes. One was to just ingest these XML files from the FTP server and bring them to our data lake in an XML format, so in the raw format. And then the second purpose of Data Factory here was to call and orchestrate a Databricks job, which is then going to take these XML files from the bronze layer of our data lake and translate them into a Delta format, which is then easier to work with in a Spark environment to continue the rest of the process of the machine learning. Ideally, we can choose what kind of data we get. We always want to work with formats like Parquet and Delta, but that's not always possible. So we have to make it work. And in this scenario, we combined together Azure Data Factory and Azure Databricks, and that gave us quite a lot of power in the ingestion part. So once the ingestion part was done, we could start the cleaning, the transforming, and the enriching step. So let's see what kind of data we are having. The data that we got from the client was data about the stores, so information on the location of the stores, some product information, so here we know what are the ingredients of each product, what is the weight of the product, and stuff like that, of which product is grouped like in which category. Another information which was interesting was the store holiday information, which at the end for us was quite valuable to see which store has holiday on which day, and then see also then the competitors' holiday information and then check, for example, I don't know, this was done in Belgium, so in a typical small, maybe Belgium city, you have maybe only 3 bakeries, and if one of them is closed, they have a holiday, you will have to produce more for that day, because you will likely have a lot more sales during the day. So that was the data that we received from the client. But we used also some external data. So the weather is typically in demand forecasting, especially for use cases like this, brings a lot of value. So we used the weather forecast for the next couple of days, but also we used the historical data to calculate for the past. And we've seen in other use cases, for example, if it's a sunny day, people are maybe going to have barbecue. So yeah, barbecue meat and beer is maybe something that's going to sell a lot that day. Another information that we used as an external data source was the holiday data. So when is Christmas, when is Easter, and some holidays like this. Because we know that people during holidays are going to buy maybe certain types of food more than others. All right, so we have our data, and we have to engineer this data, create our features which we are going to use in our machine learning models. We did this in different iterations, but sometimes we saw that the model was not incorporating the changes, the trends very quickly. So for example, when a new store was opened, that information was not immediately picked up by the model. So we, in this case, incorporated or created one feature, which is the sales of last week. And then we had to analyze the performance of the model. So we saw that there are some biases, and which are we saw that there seemed to be a bias to underestimate. And what I mean by this is that in one shop, when you have only 10 products, and those 10 products are sold, you have another shop where you have 20 products, and 10 products are sold. This is not the same, because maybe in the first shop where we had only 10 products, if we had 20, maybe also we would sell more. So here we incorporated the sold out factor, which then also was proved to be very valuable and improved the performance of our model. So that was the feature engineering part. Next, we're going to see more about the model selection and training. And here I'm going to invite my colleague Yoshi to tell you about that.
All right. Welcome, everyone. Thanks, Ivana. So yeah, about the model selection. So actually, yeah, about picking the model, it's demand forecasting. So originally, like, there's kind of 2 ways you can do it. You have ARIMA, which is like more the classical product you use for trends, seasonality, etc. And then we also have just machine learning, which is pretty hot today and pretty nice as well. Choosing between the 2, we looked a bit into the literature, and it's actually very dependent on the data and the problem when one is performing better than the other, which makes it, of course, tricky to choose. But actually, what the big advantage was in machine learning is that you can actually make a joint model from multiple time series. And that's something that's a lot trickier to do in an ARIMA model, because there really, ARIMA is really made for one time series and not like a combination of multiple time series. Especially if you're talking about combining products together, that always will make it a bit trickier. But then with machine learning, you actually can add a lot of features that actually incorporate that. So then we decided to go with machine learning. Then it was more about which model. Here as well, you have plenty of choices. We actually compared a couple of them, and in the end we chose light GBM. Because we didn't want to do anything too complicated. You can have a lot of very complicated models. We didn't really want to do that because we had some time constraints. It was a pretty small project we're doing. And also we wanted some level of interpretability for the client, which we feel in LightGBM you still can do quite okay. So then something that's also quite important is like the model granularity. And with that I mean like how many models do you want to make? Like how deep you want to go? You want to make a model per product, per store product, like you can go all kinds of different routes. And we were just thinking about all of these routes we could take, and in a model for all stores, it would be nice to have a couple of features such as the adoption level in the shop, what the location is, what the population is, certain events that are happening, like there's tons of information you could have there. But actually the store didn't really provide that for us, and of course some of these we can generate ourselves. But we thought like, yeah, probably using the store is going to be a bit tricky because like a certain town in, basically in the middle of nowhere somewhere, in Belgium that's quite often, and then a city that's going to be quite different. So then we thought like, okay, we decide on that one model for all products. Also pretty tricky because how do you actually make a distinction between different products? You can have pain au chocolat, you have a croissant, you have an eclair, you have different products, but then how do you kind of distinguish those from each other? And that's always a bit tricky to do, unless you can say, okay, we can put them in a product group. And that's actually what we did. So there, a croissant, eclair, chocolate, that's all kind of breakfast pastries. So that's one group we have. Then we can have another group like bread, which also like all of these products are quite fungible, which makes it actually quite nice to just use them together and have one model for that. So that's the road we took. We took per store, per product group, we made one machine learning model. So yeah, it's not I mean, we have a bakery here. They had like 30-something chains in Belgium. They also had like, I don't know, 200 products, but product groups we could get that a bit smaller. So in the end, we had like 248 models, which is not little, I would say. Of course, like the scope could have been a lot bigger. But we were then thinking, how should we do this in a way that actually works quite quickly? And actually, when you look at what's in Spark itself, like the MLlib, is great for machine learning, but it's not really great for training multiple models at once. So it's really made for just one model, and just doing many at once is not nice. So a for loop, of course, you can imagine that's also not going to be that great. But there's actually something really nice that you can do in Spark and Databricks, which is called the group map pandas UDF. And that's something we can use where actually it uses then the parallelization of Spark by putting these models all at the same time is training them. So you can see here I've added some code because I think it's relevant just to show it a bit, where you can actually choose like how you want to group by. So basically that's what I said before. We're training on the store key on the product group key. And then we do use the apply in pandas command just to say, okay, for this, do this function with a certain schema. So that's how we did that. And it actually worked really fast. We were also a bit surprised. I mean, we shouldn't be surprised when it comes to like data, big data, and the progress that's being made. But it actually went really fast. I think we can train these 248 models in around 20 minutes or something like that, which is quite nice because there's quite a lot of data that goes into these models. So we kind of know how we have our models, but then actually what's really nice is that we have MLflow, which is a product. I think it's open source, but it's also integrated in Databricks, which is really nice. And there you can actually track your performance and experiments. We've shown here a bit. I've took these slides from a talk on the Spark AI Summit a couple of years back, so it's been around for some time already. But actually the things you can do there is like you can manage your models, you can actually track your models, see how they're performing, what their scores were, you can try experiments, and then also you can actually have kind of a model registry where you can say, okay, this model is staging, I can move this to production now. Oh, no, this model, not that great, we're going to move it back. We select an older model. So all these kinds of things are actually really nice. And it's also nicely integrated to do some other things with it. For example, you can also do you can do some deployment as well. I think today, or yesterday at least, they announced also that they will introduce MLflow pipelines, which is something we're also quite excited about as a company. So it's like really a great product that's just evolving and evolving. So just to show you, like I was mentioning there in the apply in pandas, the group map pandas UDF, like what do you use there? And this is, for example, a kind of function you would use there. So it's a train UDF. So this is where we actually train our model. And there we use a bit of the syntax that's known in MLflow. So we use the start run to get an experiment ID. And this experiment ID actually makes it so that we can actually, after the fact, we will be able to track the certain experiment and see the model, the score, everything that's related with it. So you see we'll train the model, we'll do some predictions, and then we'll log some metrics. Like these metrics, I think that was also something that was quite nice in the MLflow pipelines. Currently, they're even auto-generating certain metrics. In our case, it was not the case yet, so we had to make some of that ourselves. And the one, like I'll discuss later as well, we used is like MAPE, but I'll come back to that one later. And then what you can do there as well is actually log your model. And that's basically saving it so that it actually is stored in a way that you could also later use it to do a deployment on the edge. In this case, not relevant, but like the framework is really there to really use it in production as well. So similarly for scoring, like quite the same structure. We have, again, a UDF. And here we just load in the model. So the model that we've used before, or that we actually trained before, that's the model that we will now be loading. And that model we'll actually then use to predict for the next day. Because this, what they basically want to know is how much am I going to sell tomorrow, so I know how much I should make today. And they also have like, it's a bit trickier for them because they have one production factory, so they have to produce and then send it out to the different chains. So they really want to know that up front, be able to plan it quite well. So we can easily do that with the scoring. So just to show you how it looks in MLflow, you can see there, for example, a model we have. Where we're actually training a certain, like this is, for example, it's store 31 and it's product group 5. And this is the model we have there. And you can see like we're training quite often actually. You can see 11 days ago, 4 days ago. And you can see then also some of the metrics that were with those runs. For example, by the way, just to give you a note, like the duration sometimes is not like, it says here it took 4.6 minutes, but it's always a bit tricky to say because everything runs in parallel, some things will be done quite quickly and some things won't be. So it's not really super relevant to duration here because it's in the pandas UDF. But like, for example, you can see some of the metrics there. And what you actually already can see here is that all of the metrics, they kind of are a bit of the same. So you have the MAPE, which is the mean average percentage error. You have the mean, root mean squared error. Like all of these metrics you can see, they're actually kind of alike. So in a sense, I think for this kind of case, it didn't matter too much what we'll choose, and I'll go into that later. But you can see at least they're kind of the same. What you can also see is that our model is like gradually improving a bit in this case, which is of course what you want to see when more data comes in. Just to show you as well, so this were in the experiments, just to show you the MLflow models as well. You can see there that you can see a certain run, and you can see, oh, this model is actually in production. And here you would also able to see, like, okay, what was the experiment that ran here? What are the characteristics? And it's actually really quite nice. So you can see everything here is done in Databricks itself. We didn't need any other integration. So scoring. So yeah, I already talked about it a bit. For this case, we didn't feel like it mattered too much which we were using. We looked a bit into the literature and felt like MAPE was just a nice metric, the mean absolute percentage error. However, we then went into a discussion with our clients, and they said like, yeah, actually it is a bit better to overestimate instead of underestimate. And of course, they are aware of the waste they will have, but they sometimes also say like, yeah, we don't really want to be also sold out because then the clients will be, of course, a lot less happy if they cannot just get the product that they want. So there were a couple of options we had here. The one we liked most was changing our metric itself to punish missing sales and to actually, having leftovers is actually less bad, where we use the production cost and the opportunity cost. And also some kind of factor for the waste itself, because you don't want to have that as well. just ecologically, which they didn't really want to provide us with these numbers, and we don't really want to make assumptions ourselves. So we actually talked to them, and what they actually wanted is they wanted to use the quantity sold, but they actually wanted it basically to be a margin. And so instead of predicting how much they will sell, they actually wanted to predict like how much they want to have in order to sell, in order to, at the end of the day, still have a bit of margin. So it's a bit of a different metric, but what they did was then they gave us all of these margins for the certain products they have, just to make sure that we don't really, if you make this demand forecasting solution, and because it's also very dependent on how many products they had in the store in the past, that always will be a bit tricky. If they one day, like Ivana already mentioned, they only deliver 10 and you sell 10, but maybe you could have sold a lot more. So this also kind of alleviates that problem, but it's still conceptually a bit tricky because, yeah, of course, you cannot go back in the past and make sure that you have unlimited supply, which would not be a great thing in any case. So what we did then as well for them was actually to work with a bit of reliability buckets, because we're training a lot of models at once. And we have MAPE, which is actually a metric that can be related quite well, like to compare other models as well, even if it's a completely different scope. And what we did there was we actually divided a bit into buckets. So what we actually did was we have some cutoff. I'm not sure anymore what the cutoff was, but everything below that cutoff, we will say, this we can predict well, you should fully trust this. This will be a great improvement to your model. Then we had a lot of somewhere, actually we would still say use this, but we could understand where maybe they're a bit more reluctant, which is, this is okay, we would actually use these predictions, but just so you know, these will be a bit less good than the other ones. And then we had some where we were not necessarily great. Of course, that's not ideal, but it's always a bit tricky. Sometimes you have products which really don't get sold all too much. Just to give you an example, they might have like some large pies, which maybe sometimes they don't really get sold all that often, but then sometimes they will do, especially in holidays. And then we're sometimes like, okay, maybe you should just make those decisions yourself, because probably there you do have a better idea than our model, just because you can really focus on the things that you feel are important. So we're there. We have our model, but now it's important, of course, we have to feed it back into the client systems. So in machine learning, you have your model. Sometimes it can be quite tricky, sometimes it can be quite easy. Here, I mean, it looked easy, but it was a bit trickier than we thought, because they need these XML files again. So they're working with this ERP system, their production depends on it. They really need this in this format, otherwise they cannot use it. So we had to, again, use Databricks to do the opposite, the conversion from just our delta, our predictions, and convert it into an actual XML file which has a prediction. Secondly, we then need to transfer these files back to their server, because this FTP server, that's how the ERP system works. It can pick up files there. And actually, Azure Data Factory could not do this out of the box. It could only do this to an SFTP server, but they were still on an FTP server. So that's something, we could not just make them switch. So we had to be a bit creative there, and there we actually introduced an Azure Logic app, which actually can use FTP as a sink, and he has a lot more data connectors that you can use. So it's actually a nice introduction, and we also stay within the Azure framework, which especially our client thinks is nice because at least everything's together. They don't have so many components, so they don't want to have too many tools as well. So just, you can see here how it looks then. So we have, again, very similar to how we had it before. We have Data Factory, who's orchestrating Databricks to do Delta Lake to XML. And then we have Data Factory, which is orchestrating via a REST API call, the Azure Logic app, which is actually doing the transfer from the XML into the FTP. All right, so running the model in production. There's a couple of things you need to take into account there. So actually, there's a frequency, and that's actually quite important. How often do you want to train? How often do you want to score? And we saw there, for example, there were some struggles. So for example, data could be weeks late. Sometimes their systems are a bit behind. There are some systems that can have pretty big delays. But actually, we need this forecast every day. And also, it seemed that weather still, like even though it's not like a barbecue shop, it still had a pretty big impact on the model. So we really want to have the latest information. And especially, like we mentioned as well, the sales of last week are important. So at least that number we really have to have as well. So that's why when we actually score, we score every day. And we already score every day for the next 3-4 days. Just to make sure that we already have a model in place. Because maybe, if something would go wrong in our model, in our structure, then at least they already have a prediction that will be quite good. Because we already used the forecast of 2 days ago for that day, which in the weather sense is still fine. But then, yeah, they already at least could have something there. Of course, what's important as well, yeah, you really need to keep control of your costs. Like running a Databricks model, like the price is quite fine, but if you do this often, especially for like this client is not a huge customer, it's not a multinational, it's a relatively small company, so the cost is definitely something to worry about here. So you actually rather do frequent scoring than frequent training. And what was also very important here is that new data is actually could be quite important. Like if you have an old shop which has been around forever, where nothing is really changing, like every new data is not that important. So like every new day is not that relevant. Of course, you want to use it for scoring. You want to make sure you have the sales of last week, but you don't necessarily want to say, run the training again, because it's expensive sometimes. And for new store, it's a bit of the opposite. There you can have the opposite, where actually new data is very important, because you're building your model, and actually, you just really want to have the latest model, train it again, because it can be quite relevant. So because they're expanding quite a bit in the number of shops, and just to keep it consistent, we decided, or actually they decided together with us, to train every week. And that's the frequency we use, which is, I think, it's a bit much probably, but I think it's fine. Like in the end, because the model is quite efficient, it's also not that costly of an operation. What is important as well is in this whole cycle is monitoring and alerting. So what we've set up here, just to make sure that, basically we have this model and we think, we train every week, we score every day, this just runs, we don't have to do much. That's not necessarily the case. I mean, things can go wrong. That makes sense. So we had some checks built in to make sure that we actually, deal with this data. So there are some checks for where the data is missing. Could be some operational difficulties. We had some issues where their FTP server was not available, so we had some issues there. So they really want to have a quick mail to make sure that, first of all, they're aware of the problem, we're aware of the problem, we can try to fix it as quick as we want to, but also they're just aware that maybe then they might need to do something else for today. Also, the client update data, so that's something actually, we've mentioned it before, the holiday information of the other stores in the neighborhood, their competitors, they actually need to input that. Because if they don't give us that input that a store is going to be closed, then also we will have it historically, but we will have nothing for the future. So then we also, there's no point in using it. So we need to make sure that they actually regularly update these files. And there we also have a mail setup to make sure that happens. Or we can have a mail setup so that happens. Also, like if there's new stores added, that needs to be added as well, just to make sure that our processes are running correctly. So that's more about the data part, but of course, the models itself, the monitoring is quite important as well. And actually, what we kind of like to do is when there's a big improvement or a big deterioration in the MAPE, then we actually want to have a mail. Because that just is a signal to us like something has changed and something is going on and maybe we need to look into it. And in the future, actually, I think there's a session somewhere here today or even in this room later about model drift, and that's something that we might want to incorporate in the future, but that of course will take some time as well to have these kinds of measures. So, to conclude, in a couple of days, and that was really the case in this project, we didn't have that many days to do it, so we had to be sometimes a bit quick in our methods, we didn't focus a lot on the model itself, but in a couple of days you already can go from just having your data to having a nice model that already can be used. So it's not the case anymore that this needs to take years or months. So that's nice. We also saw that pandas UDFs can actually help quite well in scaling because we can train multiple models at a time at like a very efficient speed. And we also saw MLflow, which is actually a great MLOps tool to just track your models, register your models, and make everything a bit more easy to see and track. All right, and that's it for me and for Joanna. Thank you guys for listening.
Thank you. I have one question on the, when you train the model or when you serve the model, deploy the model, do you do that in the same Databricks workspace or you have to do that in the different environment
Yeah, I mean, I think we do it in the same. So we have one workspace where we do training, modeling, scoring, everything is, I mean, basically, we have like only 3 big notebooks. One notebook is for our data preparation, where we do the cleaning. Then we have one big notebook where we do our model training, and one big notebook where we do the scoring. And those 3 notebooks all get orchestrated by Data Factory, and that's how our whole flow runs.
Okay, then how do you control the model version? I mean, MLflow can do the version for you.
Yeah.
And I mean, control in the sense like a human process-wise.
Yeah.
How do you make sure you deploy the right model you desired?
Yeah, I mean, for us it's a bit easier because we don't have to deploy this model somewhere in the back. We just need to make sure that we actually generate the scoring, and the scoring is just the predictions they need. So for that, actually, for us, it's kind of fine, because what we do is we train a model, and we always say, okay, this model is our current model, that's our production model, and then we use that model to do the scoring. But especially there, like, that's what I mean with the model drift, maybe. You could do things where if the model has deteriorated, or it has, like, there's something weird going on, maybe you don't switch it to production then. That's something that we probably would want to add in the future.
Okay, thank you.
Hi, a really interesting talk. One thing I was interested in is, did you manage to assess the real-world impact of your model implementation? In particular, you mentioned the customer was interested in both availability and reducing waste. Were you able to assess if at all introducing this model changed things for the better, or in fact maybe even made things worse?
Yeah, very great question, of course. Very important. Yeah, we actually, with this client, they're quite new into the scope of data. So for them, what we did, like the project's quite young still, is we have this product and they start comparing it, using it, and seeing it. So it's still a bit early for them, so they don't really use it yet, but they have been talking to us and they're really excited about it, and they really want to start implementing it. But also on their side, there's some stuff that needs to happen where unfortunately we cannot have access to, like getting it into the production. Sometimes it's a bit tricky for them apparently. So that's why, I don't have any clear numbers because, I don't have them, but they definitely are quite happy with the model and how it's doing. And we're in a close relationship with them to actually improve it over time.
Yep, so actually I have 2 questions. The first one is about the data ingestion. You mentioned using ADF pipeline to do the data ingestion from XML files. What kind of issues you face when you're doing that, especially if you have some data schema drifting with the XML files? How are you managing that? Especially we know with the raw tables and Delta Lake, it's difficult to write the data if you have schema drift. And the second one is about, you mentioned you have more than like 250 or something models. How are you pushing these models to production? Are you spinning a separate cluster for each model, or are you using one cluster for all the models, and what the cost of that?
Yeah, good question. I think for the schema, actually it was not that big of an issue for us because they have this ERP system, they feed in the sales data, and that's just very easy data to use with.
But I can add to that maybe, because we, with the Data Factory pipelines, we always put the data in the raw format in our bronze layer. So in terms of Data Factory pipelines, we never have problems, even if there is a schema drift. That's something that if there is something like that happening, that we solve it later with the delta part, where we can have easy schema enforcement and schema evolution. So we can, if the schema changed and we are aware of what changed, we can allow the schema to evolve and get those new changes.
Yeah. And then about the cluster, the model. Yeah, I think I'm not super sure about the specific. We use a machine learning cluster in Databricks. It's a bit of a different distinction. But it's not really that big of a cluster, I would say. I think it's probably only 4 nodes, pretty standard nodes. But yeah, if you contact me, I can maybe send you the exact details of that one. But actually, with a pretty small setup in Databricks, you already have quite a lot of capability, I would say.
And all the models are trained in parallel on only one of the clusters.
Yeah, indeed.
We don't use separate clusters.
Yeah.
All right, cool. Unfortunately, we're at time, but I think if you have any more questions for our presenters, just come on up.
Yeah.
Feel free.
All right, thank you again.
Thanks, guys.